Hello everyone, welcome back. In one of our earlier videos, we discussed how to find the area of one of our non-right or oblique triangles, and I want to revisit that discussion. So in our earlier video, we saw that if we know two side lengths to our triangle and the angle between them, that is enough information to find the area of that triangle. So say we knew side length A and side length B, as well as the angle in between those, which using our standard labeling convention, we would call angle C. Then what we saw was that we could write the area of this non-right triangle as 1/2 the product of the side lengths A and B multiplied by sine of our angle C. So what if instead we had a different set of information? What if we had all three side lengths of our triangle instead? Well, then we couldn't use our previous area formula, right? This area formula has A and B being our side lengths, but C is not the side length C, it is the angle C, the angle between A and B. Well, we could still make this formula work by using something like the law of cosines to help us find angle C, but that's a pretty long and tedious process to find the area of this triangle. There actually exists another formula out there that can find the area of any triangle, including our oblique or non-right triangles, using just the three side lengths of the triangle. Unfortunately, this area formula does not get a special name attached to it, but our other area formula does. The other area formula, the one using the three side lengths to find the area of our triangle, is known as Heron's Formula. So we're not going to take the time to derive or prove Heron's Formula together, but it's not too hard to find a proof online or in most textbooks. The proof of Heron's Formula, depending on how you go about doing it, is going to use some of our tools like the law of sines and the law of cosines, but overall it's just a bunch of tedious algebra that's not too insightful, so we're going to go ahead and skip that proof and jump straight to the formula. And so Heron's formula says that we can express the area of any triangle using the following formula. We're going to take the square root of the product of S multiplied with S minus A, which is multiplied with S minus B, which is also multiplied with S minus C. So little a, b, and c are the side lengths of our non-right triangle, although this would work for right triangles as well, but we have a much simpler formula in that case. So little a, b, and c are our side lengths, and this quantity S is just the semi-perimeter of our triangle. And the semi-perimeter is exactly as its name suggests. It's the perimeter and semi of it, or half of our perimeter. So remember, the perimeter is just the distance around your object. So in the case of our triangle, the perimeter is the distance around the triangle, or the sum of those three side lengths, but that's just the full perimeter. We only want the semi-perimeter. So we have to divide A plus B plus C by 2 to get this number S in our formula. All right, so now let's go ahead and take a look at an example where we're going to use Heron's formula to help us find the area of a triangle. So in our example, we want to find the area of a triangle with given side lengths of 7, 8, and 9. So from here on out, we're going to have a couple choices in how we can find the area of a triangle, either Heron's formula or our previous formula, that 1/2 AB sine of C formula. And the choice is always going to be determined by what information we know or is provided to us. So if we know all three side lengths, we're going to use Heron's formula. If we know two of the side lengths and an angle, and that angle should be between those two side lengths, then we're going to use our other area formula. So in this example, we definitely want to use Heron's formula, and drawing a picture isn't necessary, because we're just basically going to plug everything into our Heron's formula, but it's still nice to have a picture. So let's go ahead and draw one. So our side lengths are 7, 8, and 9. And so now, if we want to use Heron's formula, the first thing we always want to compute is the semi-perimeter S. So in this example, we definitely want to use Heron's formula, and drawing a picture isn't necessary, because we're just basically going to plug everything into our Heron's formula, but it's still nice to have a picture. So let's go ahead and draw one. So our side lengths are 7, 8, and 9. And so now, if we want to use Heron's formula, the first thing we always want to compute is the semi-perimeter S. And so our semi-perimeter is just half the perimeter. We have to add up our three side lengths, 7 plus 8 plus 9. That gives us 24. And then cut that in half or divide it by 2. And that gives us a semi-perimeter of 12 for this triangle. So now to finish this off, we just have to plug our semi-perimeter value into our Heron's formula. We already know the values of A, B, and C. So our semi-perimeter S is 12. That's going to be the first factor in Heron's formula. Then we have to multiply that by 12 minus our first side length of 7. That gets multiplied by 12 minus our second side length of 8, which then gets multiplied by 12, or our semi-perimeter, minus our remaining side length of 9. So we multiply these four quantities together, take the square root of that, and that'll give us the exact area of this oblique or non-right triangle. So our exact area is the square root of 720, and it's always a little bit difficult to simplify these radical expressions, but we can simplify this square root. It can be rewritten as the square root of 144 times the square root of 5, and 144 is a perfect square, which simplifies to 12. So our exact value simplified for the area of this non-right triangle is 12 times the square root of 5, units squared, whatever those units may be.